one might get the impression that you ought to know about rational functions after these, if, after you're done studying for this exam, huh? Okay, so let's break down anything that can be broken down. This is a very sweet problem because it doesn't say you have to take derivatives. Good gosh, I hope you don't. This is just regular old practice plotting rational functions. Okay, so the numerator is 0 when the function is 0, and that's going to be at 5 and negative 5. Straightforward. And the denominator is going to be 0 when you have asymptotes. So for example, x equals 2 must be an asymptote. X equals 3 must be an asymptote. Oh dear. But it's a double asymptote. I'm going to put a happy face to remind myself that this one is double. And then x equals negative 3, because this term gives me an x equals negative 3 asymptote down here. Okay. So now what do you do? Well, first of all, you don't know that my light just went out because I'm in my office and that happens sometimes. Okay, now I got my light back on. All right, so now what do? We have to figure out where to start. The zeros are a good help, and we don't want to lose track of the fact that we have a double root in the denominator. But something that just seems kind of harsh here. We got to start somewhere. So, I'm going to just start, let's say, f of 0. I don't know. Start with something. So you're going to end up with minus 25 over minus 2 minus 3 times minus 9. That's what it's going to be. So how much? All those negatives are going to cancel out, so it's positive. That's what's most important. But 3 times 9 is 27. What's 27 times 2? I did not mean to do that. Times 2. Okay, I messed up my calculator. I have no idea what I just did. But anyway, the denominator is going to be about twice as much. Does this work now? Good. 27 times 2 is 54, and then 25 divided by 52. 0.48. So about half. So somewhere up here. And then, are the wings going to go up? Both of them up, both of them down, or one of each? I don't know. So if you're really confused and you don't know where to go with this, you can always just take some points and try them. But if you know what you're doing, then you should be able to just wing it. Okay, so you should realize that in the long run, one thing you got to know is you have the y equals 0 asymptote, right? So you have the y equals 0 asymptote. However, eventually you're going to be outside the range of all your roots. Okay, you're going to be at like 1,000. And the numerator is going to be positive, the denominator is going to be positive, but the denominator is going to be way bigger than the numerator. So you're going to be approaching this asymptote, y equals 0, but you're going to be approaching it from the top. Okay, what about if x is negative infinity? Well, the numerator is still going to be positive, and the denominator, well, see, the numerator is going to be positive because negative infinity, when you square it, is still going to be positive. And similarly, you have 4 terms in the denominator here. You have 2 terms here. Okay, it looks like 1 term, but it's really 2 terms, right? So you have 4 terms in the denominator, so it's still going to be positive at this negative infinity. So you're still going to have an asymptote that's positive. So it looks like we're going to come in like this and dive down. I'm going to come in, dive down. Really, there's going to be a hump here, okay? But we're not talking about that. So I don't care if you know that and draw it. And then what are we going to do? We're just going to, oh wait, we've got a double asymptote at 3. Aha. So what do we do here? Well, see, we found all the roots for our numerator. And since there are no other roots, there's no other option but to swing around. You can't go down through here because there's no 0 there. So you have no choice but to turn around and go back up. However, at x equals 2, it's a single asymptote, so I'm going to come around down, swing, and go up. Why am I going to swing around and go up? Again, there's no zeros. So these asymptotes also break off positive and negative regions because, look at this, right here we have a root. A root is allowed to divide positive negative regions, but also an asymptote can divide positive negative regions. Okay? So hopefully that's helpful. Again, I don't care whether you know that there's a hump there. If you look at this on Wolfram Alpha, it should reassure you. Did it ask any other questions? No. So I guess that's it. Hope that helps.